Okay, so we're going to talk about linear equations. There we go. Linear equations are an equation whose graph produces a line. Okay, so it has to produce a straight line. So select the linear equation below. If you're given 3 graphs, which one's the line? C. C, there we go. So it's pretty simple when we're looking at a graph. The next one, it says the equation x plus y equals 3 is an example of a linear equation. To graph it, let's complete the table below, adding the y values. Okay, so one thing is that using the table isn't extremely helpful unless we have y by itself. So I'm just going to move the x to the other side. I get y equals x, or 3 minus x, sorry. Okay, so if I put a -1 in, what do I get?
4.
4, yep. If I put a 0 in, what do I get? 3. If I put a 1 in, I get a 2. And if I put a 2 in, I get a 1. Okay, so we're going to now take these pairs and we're going to graph them. So -1, +4. 1, 2, 3, 4. 0, +3. 1, 2, 3. 1, +2. And 2, 1, 2, +1. Okay, so clearly this equation is linear. If you guys see, it's producing a straight line. And then I say, let's mark more points and draw a line through them. So I could continue. If I drew a line through these, I'd create a line, solid line. Okay, now it says circle the ordered pairs below that are on the line. So we're going to check to see if these are on the line. So -2, -2, +5. 1, 2, 3, 4, 5. Is it on the line? Yep. 4, 2. So +4. 1, 2, 3, 4, +2. Is it on the line? No. 3, 0. So +3, 0. Is it on the line? Yes. Yep. 3, 0. You don't go up or down. Now 12, -9. Can I do 12, -9? Not really. I mean, we could kind of estimate, but I wouldn't trust our answer very much. What about -32, 40? No. We don't know. 2.18 and 0.82? Kind of hard, right? What about -7.2 and 9.6? What about 1.5 and 1.5? We might be able to estimate, but we could kind of go like 1.5, 1.5. That one might be. So I would say probably. Okay, but in general, it's not easy to tell from the graph whether some of these ordered pairs are above or on the line, but it helps to remember something important, and this is something that we're going to talk about today. It says the graph of an equation in 2 variables is a set of all of its points. Okay, so basically what it means is that if you're given an equation, it's like the kind of like the stencil for the line. Okay, so what we're going to do, if we are going to check to see if these points are on our line by simply taking and putting them into our equation. So this is your x, this is your y. My equation is 2x equals y minus 7. That's my original equation right here. So now what I'm going to do is I'm going to put x in as a 4, my y in as a 15. What's 2 times 4?
8.
What's 15 minus 7?
8.
8. Does 8 equal 8?
Mm-hmm.
Yes. So if this comes out true, then what that means that 415 is a solution. I'm gonna write this, which means the point 415 is a solution. It is on the line. We won't write that for all of them, but I want you guys to be able to look back and go, oh, that's what that means. Okay. So if this comes out true, it means that 415 is a solution of this equation. If it's a solution of the equation, it's on the line. Okay, so we're going to do the same thing with our next point. We're going to put it into the same equation. I really like to put my xy above my ordered pair so I don't forget which one goes where. The -1 goes in for x. The 6 goes in for the y. And the rest of the equation stays the same. 2 times -1 is -2. What's 6 minus 7? -1. Does -2 equal -1? No. So, not true, which means the point -1, 6 is not on the line. So you have to remember that the line is composed of a whole bunch of points. Well, this one isn't work. Okay. Last one here. We have some decimals, but that's okay because you guys get to use calculators if you want to. So 2 times -8.6 equals -10.2 minus 7. So if you did 8.6 times 2, you get a -17.2. And -10 minus 7 also gives you a -17.2. So this way you can even check those tricky decimals. Okay, so this is true. So that means that -8.6, -10.2 is on the line. Okay. That's how you test a point. So this we talked a little bit about earlier. So it says it's easy to recognize linear equation graphically, but we must also be able to do so symbolically. And so this is like when you have those equations. So not linear equations will break those rules that we talked about before. So for example, it will have the x squared. It will have x and y being multiplied together. It will have x in the denominator. It will have x or y underneath a radical or in an exponent. So those are all things that show you that it's not linear. All of these equations, even though maybe some of them look complicated, they are linear. Okay, so this is a good little reference for you. So it says, in conclusion, linear equations must have variables. So there needs to be an x or y there, and the variables may only have coefficients. Coefficients is just a number. Okay, so they can have numbers in front of them, but that's it. So let's circle the linear equations below. So first off, let's rule out ones that are not linear. Raise your hand if you can pick out a non-linear equation. Okay, Devin, which one?
38 equals 4.
Okay, so this one right here is not linear. Why not?
Because the x and y.
Because the x and y. So I'm ruling out the non-linear ones right now because of x and y. Okay, Jenna, go ahead. Yep, this one. The reason is because of the squared, right? Okay. Are there any other ones that you can see? Mason? Yeah, this one. Why? Yes, because the y is in the denominator. Y equals 0? That's a really good question. It actually isn't because it's a vertical line. So if I were to sketch this, okay, what it means is that, Oh, actually, I'll take that back. Y equals 0 is okay as it crosses the y-axis. That's what this line would look like at 0. So it's just it has a slope of 0 basically and a y-intercept of 0. So this one's okay. That's a good question. Okay, so now we are going to talk about, we can also recognize the linear relationships by looking at tables. The table below shows 3 solutions to a linear equation. Prove this relationship is linear by finding the rates of change or slope between its ordered pairs. Okay, so you guys, we haven't done a lot with, or we haven't really done anything with slope. Did you guys do some slope last year? A little bit, yep. Okay, so the slope, basically what it is you're finding the change in y, and we'll do more of this later, change in y over the change in x. So when we look here, if you went from a 13 to a 1, well, we're going to do them 3 different times. If you went from a 13 to a 1, what was that change?
12.
Yep, and it went down by 12, so it's a negative 12. If you went from negative 5 to 1, how much did it change to a positive 1? Yep, it went up 6. Perfect. Okay, so let's do, this one is 513 to 1220 and negative 21. So if you went from 13 to a negative 21, that one's kind of harder to think about. What would you have to decrease by? Yeah. Yep, so that one's going to be a negative 33. And then if you went from a negative 5 to a positive 12, you were increasing, right? By how much? Oh, this was a 34, sorry. Yep, and then 17. Okay, and then the last one, if you went from 1 to negative 21, sorry, I'm kind of moving my table. 1 to negative 21, how many did we move? Negative 22. And then if you went from 1 to a positive 12, how much did you go up? 11. Okay, so what do all these reduce to? So they all look different right now, but what do they all reduce to?
Half.
Not a half, but a negative 2. Negative 2, negative 2. They all reduce to a negative 2. So if the rate of change is the same between all of your ordered pairs, that means that it's linear. It means it's a straight line. Okay? So we're gonna work on these ones, and these ones will be easier because we're not gonna do as big of gaps. So for example, on the first one here, if I went from 1 to 2 to 3 to 4, what was my rate of, how much did it change? 1. Okay, and then what about my y's? 7 to 10, 3, 10 to 12, 2, 12 to 16. Okay, so here's the deal. You have to have the rate of change be this consistent on both sides. So this one was good, it went up by 1s, but this one went from a 3 to a 2 to a 4. So this one is not linear because it's not a consistent change. The next one, we went from 3 to 4, which is 1, 4 to 5, which is 1, 5 to 6, which is 1. If I went from a negative 1 to a positive 4, what's that change? 5. If I went from a 4 to a 9, what's that change? 5. And if I went from a 9 to a 14, what's that change? 5. So that means the x change was consistent and the y change was consistent. So that means that yes, this is linear. Okay. So my next one, my x went up by 2, and then my 4 to 6 was a change of 2, and 6 to 8 was also a change of 2. Okay, and then what about going from 3 to 4? What's the change there? 1, 4 to 6, 6 to 9. So is that linear? No, because this change was not consistent. Okay, next one, 3 to 6. What's the change? 3, 6 to 9, 3, 9 to 12, 3. Okay, 20 to 17, minus 3, 17 to 14, minus 3, 14 to 11, minus 3. So was it consistent with the x values and the y values?
Yes.
Yes, so then that means it's going to be a linear. It's going to be a straight line. Okay. The last one here, 2 to 3, 1, 3 to 4, 4 to 5, 1, 1 to 2, 2 to 4, 4 to 8. Is that consistent? No. Okay. The last type of problems are kind of like situational. How can we tell if a situation is linear? You want to make sure that it has a constant, something that is always going to happen. So if Jack makes $14 an hour, do you feel like that is a constant? Yes, every hour. So the more hours he works, the more he gets paid. So this would be a linear situation. It would produce a line if we graphed it. Each year I get a $1,500 raise in salary.
Yes.
Every year he gets a raise. This one is one of those ones that I could see going both ways. If you were charting how much he made or like how much his total would, it wouldn't be linear. But if you were just charting how much his raises were, I could see that being linear. The baby grew fast and then at first and then grew slowly. Would that produce a straight line? No. That's kind of what you're asking. If you graph this, would it produce a straight line? The cells doubled every hour.
Yes. No.
Actually not, okay? Because let's say you had 2 cells to start with. If they doubled, then you'd have 4 more cells. And if they double, you'd have 8 more cells. This is actually an exponential function. That one's kind of tricky. I get a 5% raise in salary. So this one would be probably a no because a percentage can change depending on their salary. So it might be, you know, $10,000 one year and then the next, because they're making more, it would change.
All right, kiddos, open up your book to the confusing part.
Last one, my company is losing $1,000 every month.
Yes.
Yes. Okay, so those are your linear equation